group have chosen the topic on how to differentiate algebraic functions with the use of constant rule and the constant multiple rule. And our objective is to help the viewers learn more about derivatives, to help them learn how to differentiate algebraic functions, and to be able to enhance the knowledge of the viewers and learn more about high-order derivatives. So, derivative. This is the instantaneous rate of change of function with respect to one of its variables. This is equivalent to finding the slope of the tangent line to the function at a point. So to start off, let us first discuss about the constant rule of differentiation. It states here that if c is a constant and if f of x is equals to c for all x, then f prime of x is equals to 0. But how do we differentiate a constant? Well, the derivative of a constant c is a 0. But first, we must know our constants. We must know which numbers are constants and which ones are not. If you see a number by itself or even a pi, that is a constant. And again, the derivative of any constant is 0. So here's an example. Let's say we want to differentiate 15. Since 15 is a constant, the derivative of 15 is going to be 0. Another is negative 7. Since negative 7 is another constant, the derivative of negative 7 is equals to 0. Note that if there is no variables attached to it, it's going to be a 0. So how do we prove that? Let's say we have a function and is equal to 10. Let's show that f prime of x is 0. Now let's use the definition of the derivative to show this. So we know that f prime of x is equal to the limit as h approaches to 0 for f of x plus h minus f of x divided by h. Now if f of x is 10, what is f of x plus h? Every time we see an x, we need to replace it with the x plus h because there's no x. So f of x plus h will simply be 10. So we have the limit as h approaches to 0. 10 and f of x is also 10 divided by h. So 10 minus 10 is 0. So we have the limit as h approaches 0. 0 divided by h is 0, so the whole thing is 0. Therefore, the derivative of any constant is equals to 0. So that is our constant rule. The derivative of some constant c is equal to 0. So now let us move to the constant multiple rule of differentiation. It is stated here that if f is a function, c is a constant, and g is a function defined by g of x equals c multiplied by f of x, then if f prime of x exists, g prime of x is equal to c multiplied by f prime of x. To solve for the constant multiple rule differentiation, all you need to do is to find the derivative and multiply by the constant. For example, we have 4x raised to the power of 5, 4 being the constant and x raised to the power of 5 being the function. Now we can differentiate the x raised to the power of 5 using the power rule. Now all we have to do is use the nx raised to the power of n minus 1 formula. So that's going to be 4 open parenthesis 5x raised to the power of 5 minus 1 close parenthesis. Now we multiply 4 to 5, which will give us 20, and 5 minus 1, which is 4. So the final answer would be 20 x raised to the power of 4. So guys, here we have another example. We have f of x, which is equals to 5x raised to the power of 20. And now what we're going to do next is just follow the equation or solution, which is the nx raised to the power of n minus 1. This will give us 5 close open parenthesis 20x raised to the power of 20 minus 1 close parenthesis. Now we have to do is multiply 5 by 20 and then 20 minus 1, which will give us 100x raised to the power of 19, which is our final answer. Now that we have discussed two of our topics, I would like you guys to answer it yourselves, exercise yourselves, and I hope you have fun, and thanks for watching.